All right. Let me introduce you to Coretrax. Coretrax is comprised of 3 innovative platforms. Our CX Tech that offers industry-leading wellbore cleanup and plug and abandonment solutions, such as our CX SV sliding valve, one-trip double perf and squeeze solution, our CX tubing hanger, and simple solutions to complex problems such as the CX ball back there on the table. If you get a chance after the presentation, visit the tables and let our sales associates share some information with you. Churchill Drilling Tools, a leader in downhole dart activated solutions designed to empower the end user, such as the Hyper Hole Saver. Some of you are familiar with it. The world's first hydraulic pipe recovery system. It's designed to empower the end users and allows you to disconnect when you want to. The DAV MX Circ Sub offers flexibility and reliability along with its smart dart technology and latch and seal technology. But the main reason everybody's here is to learn more about our Mohawk Expandables and how we're expanding the limit with these solutions. We offer timely, off-the-shelf, and customized solutions in regards to our expandable products. We can expand bottom up, top down, shoe to shoeless. We can deploy in a variety of different ways in drilling, intervention, and workover operations. We can set our solutions inside of 3.5-inch up to 16-inch pipe, and our longest single expansion to date is approximately 7,200 feet. The main reason that you're here is to learn more about the newest member of our product line, the ReLine wireline. So without further ado, I'm going to introduce you to the rigless straddle solution that is now available. Everybody like that? It's pretty intense. Yeah, get you going. I'm sweating because of the video, not because it's hot in here. Let me introduce you to the tool. Quick overview. Two main components of this solution. You've got your running tool and your patch, which is located, your straddle, which is located to the right here. For the running tool, it consists of a motor and pump, hydraulic cylinders, and the straddle itself at the lower end or the right side of the screen. It's wireline conveyed, and we can expand it by powering up the pump module. After the cones are drawn through the sealing areas, you simply pull out a hole. Common applications consist of this list of items, but it's not limited to that. We expect the list to continue to grow. The main differentiator between our straddle solution and other conventional straddle solutions is that we can offer you a much larger ID post-expansion. Ours being the example on the left. Operational sequence is simple. You pick up your straddle, hang it off in a C-clamp. At that point, you'd grab the running tool, one of which is located behind you, and stab into your straddle. You run and hold the depth, power up your pump module, initiate the setting process, and after you expand, you simply pull out a hole. I'm going to introduce Tyler Whitney, our engineering lead, so he can talk more about some of the benefits and the design that went into the development of this solution.
Thank you, David. So as David mentioned, we can set these really wherever you want to set a conventional straddle. The biggest differentiator is obviously the ID, but I'm going to cover a few of the other benefits that we can provide with this solution. So the first one I'd like to cover is stackability. So we can take this straddle, we can configure it to stack, and that allows us to cover a continuous interval that you guys need to cover. So here we have a video to kind of show the simulation of our stacking sub. So if you look to the left, we have a blue cross section of a straddle that we've already set. On the right, we have a blue cross section of a straddle that we're getting ready to set. And you can see there is a recessed ID that's stabbed into the top of the previously set straddle. So we simply expand these two together. There's obviously some science and math behind it, but what we get is a metal-to-metal seal with a through-bore ID. So really this is aimed at interventions. And as we know, in interventions, you're limited by your lubricator length, right? So for a straddle system, that limits the length that you can cover. With this, we can kind of get around that by stacking the straddles together. So another benefit to this system is contingency. So if we're familiar with ReLine, we know it can be finicky sometimes, right? And so it's important for us to have a good backup plan, right? So if things go wrong, what do you do? So in this case, we've developed a disconnect that goes in between the setting tool and the straddle. This disconnect serves two purposes. The first is it allows us to disconnect from the straddle in the event that the expansion is interrupted and we've set the lower seals, we've anchored the straddle. In this case, we just power down the pump. We'd overpull with the ReLine, disconnect, pull the tool to surface, and do any troubleshooting you need. In the meantime, while you're doing that, we can pick up the backup tool and simply run in with the same tool. We latch back in and finish the expansion. So I'd like to highlight that the primary contingency is the tool itself. So there's no other runs with anything else. We just run back in with the tool itself. The other function of this disconnect is it allows us to pick up the straddle section separate from the setting tool. So this is very important when you're working in an intervention scenario. Let's say you have a lift frame and you're limited on your work window. This allows us to pick up the maximum length straddle that we can get into that work window and still be able to attach it to the setting tool. So that was a quick overview. We have a few of our specifications here. I think the thing that I would like to highlight here is that these are highly configurable. We can straddle different weights of casing. As we mentioned earlier, we can stack these to cover long intervals. We've actually in the past have configured one of these to accept AICDs for controlling inflow of gas and water. So we have a live demonstration set up here. You'll see it here to my right. And while we're getting that set up, I'd like to go through a simulation of actually what we're going to expand here. So we're actually going to expand a seal section for you today. So you can see here we have a cross section of the seal and the cones passing through. In this case, we have a 3-pass seal. And one thing I'd like to point out is that today we're going to do a 50% expansion. And what that means is we're taking the ID and we're making it 50% bigger. So to get kind of a reference, typically with expandables, you're looking at somewhere between 15 and 20% expansion. With this technology, we can get much higher than that. And actually, we've installed a 73% expansion in the North Sea. So we're going to do a quick Teams call here to connect to the phone and the camera. So you're free to look at it as it happens here. This will show it a little more blown up. So while they're getting that set up, I think I'll talk a little bit about how the setting tool works. So David kind of covered that a little bit. So essentially, our setting tool is a hydraulic cylinder. So we pump hydraulic fluid in. As we pump hydraulic fluid into the setting tool, our cones and shafts are drawn up into the straddle section. So if we have a 2-seal straddle, we have these cones staged out to expand sequentially. So in this case, we have a lower seal here. The lower cone will expand the lower seal first. We stage out the upper seal to where when the lower cone has passed through and anchored the lower seal, we begin expanding the upper seal. So they've just turned on the pump here. We should start seeing movement. So we're going to bottom out the cone and you'll start seeing the expansion here happen. So while we're expanding this, you'll probably notice a few things. So as we transition from the cones, there may be some popping or jumping, and that's normal. As we move through with the last cone, we'll see the straddle section release. And y'all are free to stand up. Just please keep social distancing in mind. You can stand up and see it happen with your own eyes. And like I said, we have the camera to help you see it. So I will say, due to time, we're doing this with our test pump here. Downhole, obviously, it'll be with a ReLine pump. And we have that whole setup in the back here. So you can see the first cone is entering into the seal section. And you can see we're starting to expand. So you may ask, why do we have 3 cones? So we do this so that we can control the expansion force. So if we go all in one go, it's going to be quite high forces. But we want to be reliable. So we split this expansion up, in this case in 3. So in this case, this is probably very close to what will be happening downhole as far as speeds. I just ask that you stay on this side of the test fixture. Thank you.
What indicator is there that the expansion actually got?
So we actually can monitor the pressures of the setting tool at surface. And so we know the exact pressure signature that we're expecting when we expand these, and we can actually track that, and we can track how far the cone is through the seal. Are there any other questions while we're waiting?
So what is the pump actually doing? It's like pushing fluid from some way to some
So the pump is pushing fluid into the setting tool onto one side of a piston. That piston, or those, in this case, 2 pistons are attached to this shaft that runs through the tool. As we pump in, this shaft is being drawn into the tool. So we can make the straddle length as long as you can take or handle on surface. So that's really the limit for these, is what we've seen. So with lubricator lengths, really the max that we're seeing to be able to run is about 30 feet for the straddle section. The tool itself is about 26 feet to pick up. Once you stab them together, you lose some length, which is good.
So once the shaft gets drawn on that, then you can reset it by pushing it forward and
So-
then drawing it again?
In this case, this is all done in one stroke. So in a typical, I guess a traditional expandable, maybe it sounds weird because probably expandables are not considered traditional. But in a traditional expandable, you're actually expanding the entire tubular.
Right.
In this case, we're kind of calling this an expandable straddle. We're only expanding the seal sections.
But like in this case, you have two of them.
Yeah.
Does the tool expand both of these in one stroke?
Yes, yes. So the bottom cone will be bottomed out against the bottom seal like we see here. The top cone is actually offset from the upper seal, so that after we finish expanding the lower seal, it begins to move into the upper seal.
Oh, so you have foam all along. Like that one where he said it was 7,200.
Okay, yeah. So no. So in that case, that was a traditional expandable run on drill pipe. Yeah. So in that system, we pump down the drill pipe, set the lower anchor, and then we use the rig to pull the cone through the whole liner.
So this setup has like a thing an expander. Every joint has its expander.
Yeah. So in this case, you have to run a straddle per section that you want to cover. So.
You run each section individually?
Yes.
Okay.
Yeah. So in this is really geared towards interventions. So where you're working on a live well and you're having to deal with a lubricator. So if we don't have to deal with a lubricator or a live well, we can run some of our other solutions that are run on drill pipe or coil. I mean, coil would be considered interventions as well, but there's other options to cover longer laterals or longer sections. So you can see we're almost done with the second cone. In this transition, you'll hear a pop as the cones are transferring the load. Are there any other questions?
Did you say what pressure is in there?
This particular expansion pressure is about the max is 3,400 psi in the tool. That equates to about 40,000 pounds. Yeah, we're just expanding the seal sections in this case. So what we've typically seen is about 30 feet, and we're limited only on what we can lift, what we can put in the work window if we're limited, and then also what fits in the lubricator. So the total tool string length for a 30-foot straddle is about 53 feet. So you can see it's quite long, and we've tried to maximize the straddle length that we can run.
So this isn't a through restriction technology?
We can go through restrictions, so we do. The first one that we've run, it went through a restriction. It was a 3.5 OD, and the seal section set inside 5-inch. So that's why we had to have a very high expansion ratio for the seals. So we can go through restrictions. However, if there is a restriction, obviously we don't expand this portion, so that will be your limiting ID. So a little bit about maybe the design philosophy. We take whatever restriction you have, we calculate what we need to drift that, then we take whatever pressure that you need, we can calculate a wall thickness that we need, and then from that we calculate our upper cone. And then I'll tell you a little secret, the lower cone is a little smaller so that we don't have interference coming through. So in this system, I think we may be exiting soon. So in this system, we are limited. Our ID is based on whatever we have to pass through above.
So could you, instead of that cylinder in between, could you put screens or sleeves or anything?
We have done an application where we had an eccentric sub and we screwed in AICDs, so they're automated inflow control devices. So they automatically choke gas and water. So we've actually configured one like that. For screens, as long as the screen section is strong enough to take the expansion forces, which we have ways to lower the expansion forces, as you can see, then we can do that as well. So I think we're about to release here.
There's going to be another pop.
There's going to be a pop, and the straddle will release. Yeah. You should see some of the bigger stuff we do. Louder pops. There we go. So Wes will pull out the straddle here in a second. Okay. So they're going to bleed down the pressure. And then we can see the disconnect inside. So you can see, I mean, I see this stuff all the time. I still think that's pretty cool that we can do that. So. That's it. So, David,
Yep.
I think we have another.
We'll let everybody come take a look at this while they get it cleaned up. We added in an additional expansion for everybody that showed up today. What we're going to do is we're going to pass a cone through a connection outside. You're going to have to watch this one on the monitor, so we may huddle up around that. But we're going to give our team just a second. We're going to call it in, let them turn the pump on so you can check out what a connection looks like expanding as well. I'm sure you'll find that interesting.
This next demo is completely different from this scenario. It's more of a traditional expandable.
If we can get everybody's attention for just
Okay.
1 second, I want to introduce you to Alex Cacialupi, our VP of Engineering, so he can talk you through what we're about to do outside this door. Go ahead, Alex.
Okay, so we have also set up traditional expansion, the way expandables have been designed and conceptualized for the last 20 years. Basically, what we have right here is a 5.5 tubular OD, okay? We have a custom-made connection. This was done for a client in the Middle East. He wanted a high burst and high collapse system. So we developed a connection for them in 6 weeks, okay? From inception to threading or manufacturing. And we are testing that today. We have pre-expanded this end. You can't see very much right now, but we have pre-expanded that end. And we have encapsulated the expandable cone inside there. And we have, for simplicity, we have welded a plate in the back of it and put a port and the hose directly to it, okay? Unlike that system that expands only the seals, this expands the whole length of the liner. So basically what it consists of is basically this run down hole. You have a pre-expanded launcher, which is about a foot and a half long. It's got a drillable shoe at the bottom, aluminum drillable shoe. You can see some over there. The running tool or cone will be housed inside, and the plug is screwed to the bottom. You run it down hole. You can run as much as a few thousand feet at a time. You start pressurizing the inner string, and the cone starts traveling up, expanding the whole liner length, all the connections in there. They come in full range joints, 40 foot, and we can give thousands of feet of coverage in a well deviated or vertical, okay? So this particular example is a 5.5, and it's got a wall of 1/3 of an inch, okay? It's pretty big. Collapse, burst and collapse is 9,000, collapse is 5,000 after expansion, which is pretty high. We have done We're not going to do it today, but we have next to it done an expandable that is 8 5/8 OD with a 0.6 wall, okay? That is the biggest wall we've ever done to date. So after we're done with this expansion, we can walk out there and look at this sample as well, okay? So you can see it's already started. Yes.
There you go.
So you can see it's already started. The cone was there, now it's right here, expanding that yellow line, okay? Obviously it's a surface test, but downhole, this is a lot faster process, okay? We got much bigger pumps, so we can expand hundreds of feet at a time, okay? You can see this expansion ratio is about 11 to 12%, okay? With this system, we can go as high as probably 17% expansion ratio, okay? This will have at the bottom and at the top sealing elements, elastomeric sealing elements that expand and provide the sealing capabilities for the trouble zone you're trying to isolate. This is the connection right here. The connection is a proprietary connection, semi-flush joint. So basically it's the wall of the pipe. The connection is in the wall of the pipe. Everyone is fitted with a sacrificial sleeve that is there to protect it while going in hole. After going in hole, the sacrificial sleeve no longer serves the purpose and we can expand every connection. We haven't had one to fail yet. This connection has 100% efficiency in burst and collapse from the pipe, okay? Yeah, so hopefully you could hear me okay with the big pump running, but the sample is out there. That's the sample we expanded. As I said, we have the bigger one, 8 5/8 0.6 wall for you to look at as well. So if you follow me, if you don't mind being out in the sun for a couple minutes.